Hi guys, so today we're going to look at interest rates, and the first thing we're going to look at is what's called effective rates of compound interest. So far we've essentially been looking at annual rates, and this isn't always the case in finance. It doesn't have to be a year, it could be 6 months, 3 months, 1 month, it could be a day. An example here of an interest rate of 1% per month or 3% every 6 months. Now, if we're compounding it, then 1% per month is not the same as 12% per year, because what's happening is that 1% gets compounded 12 times, so it's going to be slightly over the 12% of the year. I think that's one of the questions that we're going to do later. Okay, so it says here, look, an interest rate of 1% per month means that 1% of the principal at the beginning of the month is added in way of interest at the end of the month. So 1% per month means that at the end of the first month, you'll have added 1%, which now means that there's slightly more money. So 1% of the principal again is slightly more than that last month that you made, and so on and so forth for the amount of compounds that you do. Okay, the time interval which interest is added to the principal converted into principal is called the compounding period. They do not have to be the same as the interest period. When they are, it's called an effective rate of compound interest. And that means we can use this formula that we've been using. Okay, so let's have a quick look and see how this works in practice, and we'll have a look at a couple of examples. For this example, guys, I'm going to do the second one first, because I think it's a little bit easier and just shows you what we're doing for the first one, i.e. we'll be doing the first one backwards. So I'm going to start with part 2 here. Okay, it says, find the annual rate of compound interest equivalent to a monthly rate of 1%, and give your answers a percentage correct to 4 decimal places. Now, I've already said, or we stated in the last slide, that 1%, we should get an annual rate of just slightly over 12%, because there's compounds on the interest that's been accrued over the month. So if we think about it, what we have is we're trying to find the annual rate, which is 1 plus I. That's going to be the annual rate. Okay, so there's the annual rate. And we know that that must be equal to, and it's going to be, it's 1%, so it's 1.01, that's 1 plus I, but we're doing this and we're compounding it 12 times. So if we work that out, it's just a case of getting it into your calculator. You get 1 plus I is equal to 1.12682503, and then we can say that I is equal to 1.12682503 minus 1, therefore the interest rate is equal to 0.12682503. So it's the 4 decimal places, so I is equal to 12.6825 to 4 decimal places. Notice how if we took the original monthly rate there, I of 1, and we multiply it by 12, we would have got 12%. And notice how this is slightly over, because, as I said, what's happening is the extra interest is being compounded. So instead of just 12%, it turns out to be 12.68%. Okay, so let's have a look at part I then. So part I is pretty much the same sort of idea. So what it says here is find the monthly rate of the compound interest rate equivalent to an annual rate of 7%. So what we have here is we know that this is 1.07, and now this is equal to, and we don't know what it is, it's 1 plus some I, which the I is what we're trying to find out this time on the right hand side, and again to the power of 12. Okay, so we're going to be solving this now. So the next thing we need to do is we need to take the 12th root of 1.07, so 1.07 to the power of a 12th is equal to 1 plus I. And you can work that out in your calculator, or you can just rearrange it. You can see if I just rearrange this slightly, I is going to be equal to 1.07 to the power of 12th minus 1. And stick that in your calculator. If you do that, you get I is equal to 0.005654145. And to 4 decimal places, it's going to be 0.5654%. Now again, if I go back to the original thing, say 7, and I divide it by 12, what you'll notice is this is slightly underneath that, just like the 1% is slightly underneath the 12.6825 divided by 12. Okay, so this is how we convert. This is just the quick and easy way to convert between annual and monthly interest rates. So if it's an annual rate of compound interest, then the equivalent monthly rate is essentially 1 plus I to the power of 1/12 minus 1, so the 12th root minus 1. And if it's the other way around, what it is 1 plus I to the power of 12 minus 1. So if we were given a monthly and we're trying to find an annual rate, we do it to the power of 12 and we minus 1 to find it. Now, if you think about it, this one is the one that we're going to use most, because if when given a mortgage, etc., you're given an annual rate of interest, and what you actually pay it is you actually pay it monthly. So what we have to do is we have to take that annual rate, change it into a monthly rate so that we can apply it and use it on a monthly basis. Okay, let's have a look at example 2. It says example 2, a moneylender advertised a weekly compound rate of 1%, taking a year to be 52 weeks, find the equivalent annual rate of compound interest, give the answer as a percentage, correct to 2 decimal places. Okay, so what we have here, we've been given a weekly compound interest rate, and we're trying to find an annual rate. So instead of using the monthly rate, which is 12 here, what we're going to do is we're going to use the weekly rate, which is 52. I'm just going to stick it straight into the formula and just work out the answer. So there's 52 periods instead of 12, so we're going to use this formula here. So we're going to write down 1 plus I to the power of 52 minus 1, and off we go. So 1 plus I, the interest rate is 1%, so it's 1 plus 0.01 to the power of 52 minus 1, 1.01 to the power of 52 minus 1. And if you work that out, stick it into your calculator, I is equal to 0.6776891, which means that the interest rate, or the annual interest rate, is 67.76%. It's quite a hefty bill. So 1% compounded weekly is an annual rate of 67.76%. So you might want to stop the video and just give this a quick read. What has happened is that lenders try to confuse people by putting things in weekly interest rates, monthly, yearly, semi-annually. So what happened was everybody got together and decided that they would have what's called an annual percentage rate, and it's the value of I, for which the sum of the present value of all advances is equal to the sum of the present values of the repayments. That just basically means per year, per annum. Slightly different for savings and investments. It's called AER or EER or CAR. It's exactly the same thing for the course. It's slightly different in real life, but we can take it that it works exactly the same as an APR. So in this example, it says a post office offers investors a saving bonds promising a 40% increase in value at the end of 5 years. What's the annual effective rate for this bond? Give your answer as percentage. Correct 2 decimal places. Again, if you think about it, 40 divided by 5 would give us 8%, which means that we're expecting this to be below 8% when we calculate it. So let's have a look. We're looking for 1 plus I is equal to the power of 5. That's for the yearly one, is equal to, and what we have is 1.4, because that there is a 40% increase. So let's work out what's going on here. So first thing we need to do is get rid of the power of 5. So 1 plus I is equal to 1.4 to the power of a fifth. And that means that I is equal to 1.4 to the power of a fifth minus 1. If you stick that into your calculator, you get I is equal to 0.0696. And that means that 6.96% is the yearly AER for this bond. So every year it makes 6.96, and that gets compounded 5 times to give you a 40% increase at the end of the term. So this is again the banks trying to confuse people. So for this one, it says for a certain type of loan the interest rate is 12% per annum compounded monthly. Well, 12% per annum compounded monthly, we know that that 1/12 the annual interest rate, 1% is applied to the capital. Therefore, after 1 month, it's going to be slightly bigger. So what they're actually doing is they're saying that it's 12%, they compound it monthly, but the AER of that isn't in fact 12%. because if it's 1% per month, we already know that that's going to be bigger, because what's going to happen is the 1% will get compounded 12 times as it goes through. So just be aware that that's what we call a nominal interest rate. So the expression 12% per annum compounded monthly isn't 12%. It's actually 12.68, as you can see from the maths here. We've already done this. And it's just another way of trying to confuse people. So nominal rates are different to effective rates. So the effective rate, or the annual equivalent rate, is 12.68 here, whereas the nominal rate is 12%. They're just trying to confuse you. You can see if R is a normal annual rate, M times per year, blah, 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 blah. You can see that we use this formula in order to work out what the equivalent annual rate is going to be. So you can see an interest rate is quoted as 8% per annum compounded quarterly. That tells us it's going to be a nominal rate. So you need to find the percentage correct. 2 decimal places, the AER. Okay, it's just using that formula. So let's just write down what that formula was. It's I is equal to, and it's 1 plus R over M to the power of M minus 1. Okay, we're trying to find R. We know that the rate is equal to 0.08. We know that the M is equal to 4, and we just stick it through the formula. So I is equal to 1 plus, and it's 0.08 over 4. The power of 4 minus 1. I is equal to 1 plus 0.02 to the power of 4 minus 1. I is equal to 1.02 to the power of 4 minus 1. Whack that into your calculator, and you get I is equal to 0.0824316, and that means that your interest rate is equal to 2 decimal places. It's going to be 8.24%. Again, slightly more than the given rate of 8%, because instead of doing it per annum, we're doing it quarterly, which means there's going to be slightly more interest on it.